Good morning. Your student Dolphy Gilpin is here with you this morning. We are continuing with our CME, and in particular we are on the periodic table. Now, in previous video lectures we had introduced our periodic table, and we just like to sort of expand on it this morning. Notice that this morning we have two periodic tables. One which is the original one that I started off with a little extension of it, and to a second one which I've sort of made bigger so as the data would be more explicit. So here we are with our original periodic table, and we're focusing now on the groups. Notice on this one we have 1, 2, 3, 4, 5, 6 to 18 groups, and I hope you could see these numbers up top here representing the groups, and these coming down here, the periods 1, 2, 3, 4, 5, 6, 7. Now in the periodic table, group 6 here, 55, 56, and you notice after 56 we have 71, which is the lactinide and actinide series was integrated in this section of it. And down here in group 7 we also have 87, 88, and then a big gap from 88 to 103. This is also where the lactinide and actinide series was integrated into the periodic table. The idea was that if they didn't do it this way, then it would have taken up too much of a white space. As you notice on this one here, I've actually included in period 6 and 7, from cesium to radon, and from francium to octium. You notice I did the whole extension, and this would consist of 32 groups going across. We'll stop at 18 here. This would have consist of 32 groups going across. So in actuality, it is said that this version is a more accurate version if we would have included all from 55 to 86 here, which is from cesium to radium, which is not so on this one. We have from cesium and then barium, and then we have La, which is in group 3 and period 6 with atomic number 71. So from atomic number 56 we move on to atomic number 71. It should be 57, but like I said, they have actually chopped out a piece of the periodic table and bring it down so that it would abridge the width of the periodic table. So if we insert this back, we'd have 57 here, 55, 56, 57, which is the La, and 58 Ce, 59 Pr, 60 Nd, and so on and so forth. We're now over to 71 there. And I've shown it here in this periodic table, in which I've introduced the continuity of it from 55 through to 86, which is from cesium to radon, and from francium in period 7 to octium. And notice from after 92 that most of these elements are man-made synthesized elements, artificial, but that up to 92 they were all natural occurring earth elements. Naturally occurring is up until about 92, and then afterwards we have the artificial elements synthesized in laboratory and given names after scientists and after a systematic notation of nomenclature. So that's the periodic table. And also in our expanded view here on top, I've introduced my own color scheme on it I started off, and what we'll be doing is that we have used green on some of these elemental blocks, the color green, and we have used green and blue. For example, take for example uranium, which is 92. We have used blue and green, blue representing protection. And I've done something here that is a bit unorthodox. I've integrated faith, religion with science. And I've used the color scheme of the archangels here, blue representing Archangel Michael. And he's the archangel, chief archangel for protection. And the color blue in that radiation band is assigned to him. Green is assigned to Archangel Raphael for healing. Archangel Raphael with our Mary, Mother of Jesus, for green. And since some of these elements will be focused on in healing, will be brought into health and medicine, I have color schemes of them green. For example, you have sodium here. With an excess of sodium in the body, we'll have hypernatremia. Deficiency, we would have hyponatremia. For excess of potassium K, which is in green, we would have hyperkalemia. And for deficiency, we'd have hyperkalemia. For excess of calcium here, we'd have hypercalcemia. And for deficiency, we'd have hypocalcemia. And so I've put these in green. Blue, uranium, which is labeled one of the most dangerous elements because of its nuclear capabilities and what it had done to Hiroshima and Nagasaki in that bombing. They said it's labeled as the most dangerous element, and I've put the color blue scheme there. But some of these nuclear elements have medical properties and applications in nuclear medicine, and we'll touch on that in later expanded lectures. But we're just introducing them now. Thallium is labeled as one of the I think one of the most toxic elements, thallium, and also we have color scheme with both blue and green, predominantly blue for protection. I think this one is used in for insecticides and for rat poisoning and all of that thing, but they have reduced the usage of it because of its danger in that it is colorless, odorless, and tasteless. It makes it more dangerous. It's hard to detect now, and so thallium, this poisonous thing, has been reduced into use to as a poison for rodents, like laboratory, another insect that they used to use this thallium for. It, along with arsenic, is one of the two most poisonous or toxic elements. So like I said, now I've introduced this color scheme, which will be my color scheme. I've been using the 7 Archangel color scheme. Some for protection, some for healing, some for wisdom, and all of that jazz. But for now, we have just used the green and the blue for healing and for protection. Archangel Michael, Archangel Raphael, with Archai, faith and virtue for Michael the Archangel, and Archai, Mary Mother of Jesus for healing, Queen of the Archives or angels. So that's something unusual I've done here, integrating, combining both faith and science. Notice here also that in these groups, you have group 1, which is labeled as the alkali family, and 2, the alkali earth metals. 3, let's get a look at it. 3 is 3 to 12 is the transition elements. 13 is the trials, 13, the group 13. 14, the tetrael, which is the carbon family. 14, carbon, silicon, germanium, SN, tin, PB, lead, and so forth and so on, coming down. 15 is the prectogens or the nitrogen family, 16 the chalcogens, the oxygen family, 17 the halogens, chlorine, fluorine, chlorine, bromine, and all of that. We might be changing up some of these color scheme here soon, because right now we have only, I was starting to use color scheme from the, what we call the internet, but for me, then I start to adopt my own color scheme in labeling some of these group and periods my own color, which I've chosen green for healing and medicine, and blue for protection. Uranium protection because of its danger, and some of these other artificial, synthetic nuclear sort of elements would be color scheme. When we come to that bridge, we will cross it. So once again, I have two periodic tables here now that I've drawn, and this one is showing that from group 6 and 7, whereby the lanthonide series and the actinide series was taken out from 56, 57 onward to 103, and because of the width, they wanted to reduce the width, really, so that what in actuality and in all precision and more accuracy, what we have is like a 7 by 32 matrix in certain cases, because these things would be extending up to 32 instead of 18. And that would leave us by a 7 by 32 matrix, stochastic matrix, which a lot of these elemental blocks would be also void or blank. Hydrogen of itself, although it's in the alkali group, is said to be in a group all by itself because of its unique properties. So hydrogen can be taken out really, but it is there in the alkali earth metal group. The alkali earth metal group would be group 2, and the alkali would be group 1, and from group 3 to 12 would be the transition metal. Also, if you draw the imaginary diagonal across here from boron coming down, what you'll have to the left of the diagonal would be what we call the metals, and to the right would be gases. But we have exception to that rules. Some of these over here have more non-metallic properties, and over here have more what we call the gases, and the non-metal have also elements that have metallic properties. But as a rule, to the left of this diagonal line here would be metals, and to the right non-metals. Also, those consisting in the line, some of the element in the band of the line here would be in between metals and non-metals, and they are called semiconductors or semi-metals, having properties of both metals and non-metals, or semiconductors. So to the left is metals, to the right. And a special group here, A18, is the noble gases. Also, let's just take one look at the artificial synthetic elements. From 118, 118 would be, it's not mentioned in the upper periodic table. In the lower periodic table, 118 would be un octium, 117 un heptium, 116 un exium, 115 un pentium, 114 un quadrium, 113 un trium, 112 un bium, and 111 I think that then it starts to have a different nomenclature there, unil, ium, and so on and so forth. So those are the synthetic elements that were discovered in the laboratory and giving names, some of them after the scientists that discovered it, or the chemists, scientists that discovered it. So that's a little more, shedding some little more light on the periodic table. We will take a break, and then we'll come back to describe now our pharmacochemicals, the extension of our Amz5x12MIPCA series. So in the pharmacochemicals, we know here one thing again, that the basic elements of carbon, hydrogen, oxygen, nitrogen, sulfur and phosphorus are used in most of the synthesis of the pharmacochemicals. And then we come on to use sodium and potassium and calcium. Well, yttrium was the one that was used with some radioactive property to make precision needles for spinal operation of the spine, and for knee surgery and all of that jazz. It's also used in light emitting diodes and so on and so forth. But we'll come to take a more in-depth look at these elements individually and in synthesis, in compound synthesis, in medicine and other scientific use. So with this, we're going to take a break from our extension of our two periodic tables here, and we will return with some more insights on the periodic table.